So if you launch your Eclipse, and then I don't think we're going to create any new projects today. Yeah, they just stay in Lab 1. Okay, for now. Actually, Lab 2 might be better. Okay, Lab 2. Let's have Lab 2. Okay, let's say OK. And then we create a new project. So don't worry about the points example we did from Monday. We're just going to create a brand new example from scratch. Okay, so now can we just create a new project? File, new, Java projects. CSE114, Spring 16, Week 11, Lab 2. Week 11, Lab 2. Okay, so now under Lab 2, let's create a rectangle class, new class, and let's call it rectangle. Rather than points, let's have rectangle. Rectangle, yeah. Okay, there's a class here, and let's say we got two simple attributes for rectangle. Let's say we have double. Let's make it even simpler. Integer. Integer. Let's say width. Integer length. And let's say in the constructor there we have rectangle, integer width, integer length. Okay, this dot width is assigned to width. This dot length is assigned to length. Okay, let's now define an accessor method which will return the area of the rectangle. So in that case, because both width and length are integers, so of course the area is going to be integer as well. Integer, that's a return type, and then get area. Okay, so here you can simply say returned, and then width times length. Or if you prefer, the pattern we talked about just a couple of hours ago in the tutorial, what you can do is you can declare integer, let's say this is the area we'd like to return. Initially just 0. And then eventually we would like to return this area value somehow. And in the middle, we say area is assigned to width times length. If you don't prefer the one-line solution to get an area, you certainly can do this, if that makes more sense to you. Okay, like that. That'll be it for now. And then we'll go to the project here. Let's create another class. Let's call it rectangle tester class. Rectangle tester, and with the main method, of course. Let me just plug off. Yeah, let me just plug off my power. Otherwise, my battery's gonna die. Okay. Okay, so now for the tester here, we're gonna create two rectangles, which don't really have the same width and length, but their area are actually the same. Okay, let's create rectangle 1. Rectangle, let's say R1. Assign to new rectangle. Let's say, I think width first, right? Okay, width and length. Let's say 3 by 4. Let's say another rectangle here, R2. New rectangle, let's say 2 by 6. You can see the width and length are completely different between the two rectangles. Let's double check with that. So you can say now system dot parent line. So here you can say area of R1. You can say plus R1.get area. Similarly, you can just copy that line and just change it to R2. Area of R2, R2.get area. Okay, so let's just double check that the areas are the same. Okay, 12 and 12. Okay, nothing tricky so far. So let's say we would like to let's do the following. Okay. So now if I say system.out.println, let's say R1 equals R2. Okay. Of course, if you're prepared for your midterm, you must know what this really means. So what does R1 equals R2 mean? What does it mean really? What are we trying to do? Okay.
Asking the address of it.
Yeah, exactly. So R1 stores the address of some rectangle. R2 just stores another address to see the addresses. So in the test, you should say we are comparing the addresses in R1 and R2. Okay, so in this case, would that be true or false? False, because you can see R1 comes from line number 5, which is a new expression. R2 comes from another new expression, R2. That's good, you know. Let's double check with that. So let's build up step by step. That's false. Very good. So now, one thing to note, although I mentioned that already briefly on Monday, but that's kind of in a rush. Have a look at this. Rectangle class here, we did not define the equals method, which we did before. We did not, okay? So now, if you try this, if you say system.out.println, so let me put here, it's a R1 dot equals R2. And then here plus is a R1 dot equals R2. First of all, it compiles. Although we did not declare or define the equals method in the rectangle class, but somehow it compiles. Isn't that strange? I can tell there's nothing wrong with Eclipse. It should compile. Okay? There is a reason for this, which I didn't tell you because we haven't learned about inheritance. But since now we have learned about inheritance, so now we can say that. Okay? So now there's something I need to draw on the board. So in Java, so since now we talk about inheritance, we know the notion about parent class and child class. So there is one class that is the parent class of every class in Java, which is called objects. Okay, that's something you must know. Okay. Let me just mention that now. Also, I'll show you some slides. So now, if you see, let's say, remember, so far we just have a rectangle class. Rectangle class. And implicitly, every class in Java has a parent class called objects. So object is a class that's in the library, which means whenever you have a new class that's defined by yourself, there is an implicit parent class called objects. Okay? So that means whatever methods that are actually defined in the object class will be inherited to the rectangle class. And guess what? The equals method is one of them. That's why the code there just compiles. It's a little bit like this situation here. Okay, think about this situation here. So now remember we actually defined the student class before. Student class. And also we got resident students. And also we have non-resident students in our S. Okay, like that. Remember there was a method called register course method here. Register course. Okay, that's in the parent class, so it will be inherited to both classes over here, right? And we did not explicitly define or redefine this method anymore in these two classes. That's what we have. So now consider this. If I say resident students, let's say RS1 is assigned to new resident students, some name over here. So now I say RS1 dot register course. And then maybe I give CSE114, assuming that it's there already. So now this line here will compile, simply because although I didn't explicitly declare the register course method here, but since it was inherited from the parent class, so that's why you can use it. Similar situation here. Although I did not explicitly declare the equals method in the rectangle class, but because it was declared in the object class, so it is uninherited to here. So that's why you can use it. I'll stop here. So if you're lost, raise your hands, please. No? Only GL, really? Then we are doing very well. Okay, that's fine. Let me try again. Okay, let me try again. Okay. Are we okay with this part here? Okay, first of all, we got students, we got resident students, and we got non-resident students. Agree? Okay. We only define the registered course in one single place, in the student class, right? In these two classes, the child classes, we did not say anything about registered course. Okay, let me remind you about it. So if you go back to your lab exercise 1, okay, go to the package called with inheritance. Okay, I'll show you here, but you can refer to it later. So if you go to resident students class, you can see resident students class extends the student class. You can see over here, we did not declare the registered course method. It's not there, right? Remember, I made a comment saying that there is no need to redefine the registered course method. It's completely inherited from the student class. So if you go back to that package there, you can see in the student class, that's the only place where we define the registered course method. That's the only place. But since the resident students is a child class of that, so you can just use that method without any trouble. So that's why this line of code will compile. So now we have a similar situation now. Because I said before, the object class in Java is the parent class of every class. It's by definition. There's nothing you can challenge about it, just by definition. So now in the object class, one of the methods is called equals. Just called Boolean and then equals. Equals method here. So now because object class is a parent class of every class, so this method here will be inherited into the rectangle class. Right? So that's why when we say rectangle R1 dot equals R2, it will compile, even though we have not explicitly defined that yet, because we simply just inherit whatever definition it is over here into here. Okay, can you follow the logic here? Okay, that's something first of all to know. Okay, so far I try to explain why this line here. I'll make a comment for you. Okay, so you can also think about it. Okay, so now let me and then I'll show you some slides. So here, this line compiles because the equals method is defined in the object class, and we know that the object class is the parent class of every class. So the equals method is inherited. That's the reason why this line compiles. That's the first thing we gotta get clear about. Okay, so now the second issue. Since we inherit this equals method from the object class into the rectangle class, so now we have to see if this equals method indeed compares the areas of the two rectangles. Okay, that's something we want to see. If it does, then we are done. If it does not, then we may have to redefine the equals method in the rectangle class. Okay, that's sort of the story. Okay, so let's see this. If you simply launch the program, you will see that R1.equals R2 returns false. Remember we said before, areas of R1 and R2, they are the same. So R1.equals R2, we would expect that to be true, but apparently it is not true. So why? There is a reason for that. Okay. To make this long story short, the equals method that is defined in the object class does not do any contents comparison. It only does reference comparison. So what do I mean? I'll show you now. Okay, so now let's try to do this. Okay, if you put a breakpoint over here, line number 17, right before we do R1 that equals R2, let's try to make sense of that. Now if you say run debug as Java application. So now here I stop here, right before I execute R1 that equals R2. So now let me ask you this. If I say step into, where would I step into? The equals method, right? But where is the equals method? The equals method was actually defined in the object class, right? So that's something I'll step into. And let's see how the equals method in the object class is defined. And then we'll see exactly why it is wrong. It is inappropriate. Okay, so now if you say step into over here, so now you will see that, oh, not yet. So that's just a string. Okay, step over. Now step into again. Okay, so now you can see we are in the object class over here. And now we are in the equals method. And please stare at this line a little bit. The equals method in the object class is defined very simply. In only one line. It says that this equals objects. So it is comparing the addresses by default. It is not comparing the contents. So that means if you think two rectangles are considered as equal, if their areas are equal, you should really try to redefine this equals method over here. Otherwise, it is simply going to call the inherited version from the object class, which compares the addresses, as you can see over here. Okay, let me show you some slides. Hopefully slides can summarize this quite nicely. Okay, so now, first of all, every class is a sub-child class of the object class in Java. So the slides are already available online. And then, okay, the object class is the parent or superclass of every class. So now, so there are two accessor methods that are actually useful for us to use from the object class. The equals method is one of them. There will be another one which I'll show you in a moment. Okay? So we're going to learn the two methods today. So now, the equals method is already defined in the object class. And the default definition is the one we just saw over here. So let me show you this. So you will see that more clearly. Let me wipe this out. Okay, so here we got the equals method here. Let me just copy down the definition, which is very short. So now I have Boolean equals, okay, so some other objects. Okay, we simply just do this equals, return this equals other. Equals other. Okay, what does this mean? So now when we try to say R1 rectangle 1 dot equals R2, if we say that, so now in this case, because we did not declare any redefine the equals method here, we did not. So that's why we're going to inherit this version into here. Okay, so now when we try to run this, other is going to be replaced by R2. Other is going to be replaced by R2. And this will be replaced by the context objects, which is R1. And it's simply going to return R1 equals R2 by default, if we did not redefine the equals method. Better? Okay. So my point is, if you think two objects are, if two rectangle objects are equal, if their references are equal, then that's okay. You can just reuse this definition here. If you think there should be something else you want to compare about, for example, areas, then you have to redefine this method explicitly, which I'll show you how to do that. Okay, so that's the default definition there. Okay, and then also there's another method which will be useful called toString, like a get description method we talk about in the banking system. I'll talk about that in a moment. Okay, so very often you will have to redefine the equals method in your class. Very often. So now let me go back to Eclipse. I'll make more comments for you. And then we'll just try another version. Okay, let me just go back to Java here. Okay, close that. let me only leave, let me close all. If you go back to that rectangle tester, okay, let me say something else. By default, the equals method in objects in the object class compares addresses only. Okay, so the line below is as if we wrote R1 equals R2. Okay, that's very important to note. That's why now R1 equals R2, and also R1 that equals R2, both of them return false. Okay, since we have not redefined the equals method. So now the next question would be, how do we redefine that, right? So now let's create another version of the class. Now I would like you to just create another class here. Let's call it rectangle2. New class rectangle2. Over here. So now basically it's the same as rectangle1. So again, we have integer width, integer length, and also we have rectangle2 constructor here. So integer width, integer length. This dot width, this dot length is assigned to length. Pretty much the same as before, and also we want to get area. Get integer, get area. The same as before. Let's just return width times length. Okay, up to now it's identical to rectangle1. But now we're going to do something slightly different. We're going to explicitly redefine the equals method because we think two rectangles should be considered as equal if their areas are equal. So we don't think the default behavior for the equals method on the object class is appropriate. We don't think. That's why we have to explicitly redefine that. So we do not, let me write something here for you. Let's say the inherited version of equals method from object is not appropriate, i.e. they simply just compare addresses. Okay, instead we redefine the equals method to compare areas of two rectangles. Okay, that's what we want to do. That's kind of the flow of the story. So now how do we do that? Okay, the way we do that is simple. The equals method is going to return a Boolean. And then gotta make sure you print this out the right way. EQUALS, equals. And then for the purpose of this course, you can just copy the name of the class and then put it here. So which means we are comparing the current rectangle 2 with another rectangle 2. So just call it other here. Okay, so now we would like to say two rectangles are equal if their areas are equal. So now you can simply, let me just do a slightly longer version. So you can say Boolean result. You can say result is assigned to this dot get area. Okay, equals other dot get area, and return the result. Once we have done this, we will be guaranteed. Next, we're going to write another tester code to make sure when you actually try to compare two rectangles of type rectangle 2, the equals method is going to be called this version here to compare the areas rather than the version that's inherited from the object class. Okay, we're going to see that. So what you should really notice is rectangle and rectangle 2, So these are the two classes that only differ in this equals method. In rectangle 2, we try to redefine that explicitly. Okay, so let's just go back to rectangle tester. Okay, let's do something very similar. So now we're going to say rectangle 2, right at a rectangle. Okay, rectangle 2. Let's say R3 is assigned to new rectangle 2. Let's do exactly the same. Let's do 3 and 4. Okay, rectangle 2 R4, new rectangle 2, 2 and 6. Let's first print out the area of the two rectangles. Okay, so you can say system.out.println. Let me just give more. Println area of R3 is, so you can say plus R3 that get area. Okay, system.out.println area of R4 is R4 dot get area. Okay, it's going to be 12 for both cases. So now, let's do again the two comparisons as we did before for rectangle. So now you can say system.out.println. So now if I say R3 equals R4, so don't get confused. What should this return? False, right? Because we're still comparing addresses because we're using equal. Let's just double check with that. Okay, still false. Okay. So however, now if we do system.out.println, if I say R3 dot equals R4, let's see what's going to be the result. We would think that should be true. Then otherwise, what's the point of doing this, right? Yeah. Let's see. Yeah, it's true. But why? Okay, let's see why. So let's remember we put a breakpoint before over here. Can we just remove that breakpoint by double clicking on that? So let's put a breakpoint in line 30 in my case, so right before we say R3 that equals R4. Okay. So now if you do run debug as Java application. Okay, so now we're here. So now if I say step into, remember, so in this case here we got two versions of the equals method. Two versions. Let me show you on the board. Two versions. So now imagine that, remember we actually got a new class called rectangle 2, right? So now we somehow redefine the equals method here in this class, also other here, and we simply say return this dot get area equals other dot get area. So you can see we got version 1 and version 2, right? So now in this line here, if I say step into, we should expect to get to this version instead, right? Rather than this version. But this version is going to give us false. And this version here is going to compare the area, which will give us true. Let's verify that. So now if you say step into. Okay, not yet. So that's a string. So just step over again and step into. So now we are now in the rectangle 2 class and the equals method, right? And that one is going to compare the areas rather than the addresses. Okay, so that's why you will see actually true over here. It's a small example, but it's a very, very important point I'm trying to illustrate. Okay, so again, let me just clear the board and I'll summarize what I've just said. It's very important. If you don't understand, on Monday you will actually get lost even more. So let me just wipe this out. Okay. So in Java, there is a class called objects. And by the way, you can actually look up the object class if you like. So let me show you how you can search for the object class. So if you go online, if you Google, let's say, so what you need to type Java API object. Okay, so go to the API for Java objects. You'll see this. Class object is the root of the class hierarchy. The root simply means it is a parent class of every class. Okay, so you will see that in the object class, there is the equals method. So that's a method I was talking about. And then there is also another one which we'll talk about today, which is called the toString method. So these are the two that we're going to use for the course. Okay, and if you click on the equals method here, and okay, so now I want you to see. You can see that simply do x equals y. So they simply do the address comparison rather than any contents comparison. It is generally necessary to override the method to actually get the contents comparison. Okay, that's something you can look into further if you're interested. But I'm just pointing to you where you can find it. Okay, let me keep saying this. So we got an object class. That will be the parent class of everything. And one of the methods that it supports is the Boolean accessor. The Boolean equals. Okay, take something here. And of course, the default definition would be, let's say it's other here. You say this equals other. Okay, so return that. Okay, that's a default definition. So any class that you define by yourself is going to inherit this version, first of all, unless you actually redefine them. So in the case of rectangle, we did not redefine this. Okay. In the case of rectangle 2, we did. Rectangle 2. So over here we say also Boolean equals and also other here. Okay, so here rather than returning the address comparison, we say return this dot get area equals other dot get area. Okay, you can see now again in rectangle class there's only one version that is inherited from the object class. In the case of rectangle 2, you got two versions over here. So that is why when I say step into, you actually got different versions of equals method. Again, when you say R1 dot equals R2, in this case, it's going to be false. When you say R3 dot equals R4, in this case, it's going to be true. Is it clearer? I hope. Yeah. Okay. So far, so good. I hope. So now, let's see how we can develop a little bit further. Okay. So let me just tell you that when you go back to the slides, you can see that I actually give you example here. That's exactly the thing I'm going to do in the lab. So you got rectangle, and also you got rectangle tester, rectangle collector. That's something I will do in a moment. So please, by Monday, maybe after the midterm, that's exactly what we're going to do in a moment. And just go over the slides and then make sure you're okay with that. Okay, but we're going to do everything now. Yeah. Okay, good. And you'll be up to slide 27. And then we'll start from slide 28 from Monday. Okay, that's the plan. Let me now go back to Eclipse. Okay, let me close the slides. So now let's develop further about collector. Okay, so now can we just go back to the Java here, and then if I go to Package Explorer, so now let's say I would like to have a rectangle collector. Okay, again, I'm going to have two versions of the rectangle collector. In one version there, I do not explicitly redefine the equals method. In the other version, I will redefine the equals method to show you again the difference. Okay. So now let's first of all, let's create a new class called rectangle collector. Rectangle collector. Okay, so this one here, just easy, just one rectangle array. Rectangle array. You remember this rectangle here is the one that did not explicitly redefine the equals method as a version. Rectangle here, and then let's say rectangles. Okay, also we have some counter, integer number of rectangles. Okay, let's have rectangle collector constructor here. So now you can say rectangles is initialized to be a new rectangle array. Sorry, new rectangle array. Let's have size 10. Okay, let's not worry about the constant decoration. Let's just to make it easy. New rectangle array. What did I do wrong? I'm pretty sure, yeah. Thank you. Yes, good. Okay, that's the constructor here. And of course, you can also say the number of rectangles is assigned to be 0, but it's not really necessary. It's a default value anyway. Okay, let's see how we can implement the add a rectangle method. Void add rectangle R. Okay, I'll give you 30 seconds to complete this. I think we have done this maybe more than 10 times already. Hopefully you almost memorized it, almost by heart. Okay, so without any surprise. Okay, and let me make a comment here. We do not redefine the equals method that is inherited from the object class. We do not, okay? So that's why we leave it just like that, okay? So that's the rectangle collector class, that's it. So now, if I'll update the diagram in a moment, okay? So now let's go back to the tester. Okay, let's develop a little bit further. Okay, so now I may just have to start the debugger myself. Okay, so now in the tester here, so let's say we create a rectangle collector. Rectangle collector RC1. New rectangle collector. Okay, so let's have another one. RC2 maybe. Rectangle collector RC2. New rectangle collector. Okay, RC1 and RC2. So now I would like to add R1 into RC1 and R2 into RC2. Okay, so now I'm going to do the following. So I would say RC1 dot add rectangle R1, RC2 dot add rectangle R2. So we got RC1 and RC2. So now I'm going to do similar comparison to see RC1 equals RC2, and also RC1 dot equals RC2, and see what's going to be the result. Okay. Let's see this. Need to see the time. Okay. Oh, okay. System dot out dot print line. So RC1 equals RC2. So this one should be no surprise to you. RC1 equals RC2. So that should be false, right? Since we're comparing addresses, there's no way they can be different. They can be the same. Another one. So system.out.println. We say RC1 dot equals RC2. plus rc1 dot equals rc2. Okay, so now you can see that we are trying to call the equals method. The question you gotta ask yourself is, which version of the equals method it is going to call?
The object or no?
Why?
Because we don't have an equals method for the rectangle collector.
Exactly. Precisely. Yeah, that's exactly what I wanted to hear. Yes, let me just repeat it again. So basically, in the rectangle collector class, we did not redefine the equals methods. But the only version that exists will be the one inherited from the object class. Right? Very good. Okay, let's try this and then make sure that's the case. Okay, yeah, so you can see rc1 dot equals rc2 is actually false. Okay, very good. So now, let's go further to see how we can make this work. Because somehow we want to say, well, if you want to compare two rectangle collector, you want to compare each rectangle in there individually, right? That's something we want to do. You can also refer to the slides. That also tells you the detail. So let's just create another class. Similar to the case where we got rectangle and rectangle 2. So now we're going to create another class called rectangle collector 2. Okay. New class rectangle collector 2. Okay, let's not copy and paste. Let's type. If I do copy and paste, that might be too confusing. So let's say here. So now here, be careful. Okay, rectangle 2 here, not rectangle, rectangle 2. There's a reason for that. I'll show you in a moment. Rectangle 2. Okay. Rectangles. Okay, it will not work if you simply say rectangle. Okay, you gotta say rectangle 2. Okay, rectangle 2 is a version where we got the equals method defined for the rectangle, right? To say they compare areas rather than references. And also we got a counter here, number of rectangles. Okay, let's have the constructor here. Okay, in this case, we're gonna have rectangle assigned to new rectangle 2. Let's say 10. And also the number of rectangles is assigned to 0, let's say. Okay, again, let's have a mutator method. So void add rectangle. Okay, so now you can say here it's going to be rectangle 2 R. Okay, this one read the same. So you would say rectangles add the number of rectangles assigned to R, the number of rectangles plus plus. So now here comes the difference between the two. We redefine the equals method inherited from objects. We say two rectangle collectors are equal if the rectangles they collect are equal. Well, it sounds easy in English, but if you do that in Java, you gotta be careful, right? Yeah. But yeah, that's, it's okay. It's a natural language, so it can be fake. But let's see how we do that in Java. Okay, let's see how we do that. Okay, so now we say Boolean equals, so rectangle collector, okay, other. Oh no, rectangle collector 2. Yeah. Yes, absolutely. Thank you. Yes, very good. Very nice. Okay, so now we're going to define this. So first of all, we can say that the two rectangle collector class must have the same number of rectangles, right? So you would say if the this dot number of rectangles equals other dot number of rectangles, then they have the potential to be equal. Otherwise, there's no way they are equal. Otherwise, you can, let me just do something here. I can say Boolean result. Okay, so here I can say result would just be false. And eventually I'm going to return the result. So now I have to see in the if branch, how am I supposed to update the result, right? So now I'm in the if branch here. Both rectangle collectors have the same number of rectangles. So now we can run a for loop to actually compare each one of them. So now I can say for integer I equals 0, I less than the number of rectangles, I plus plus. Now, here comes the thing. I would like to compare one by one, okay? So the version I show you on the slides has the early exit, saying that as soon as I find out if there's any two rectangles are not equal, I'll exit from the loop, okay? So I'm going to show you the one without any early exit. You can say result is assigned to result conjunction conjoined with, okay? So here comes the critical part, okay? So how do we update this? So first of all, you can say this dot rectangles at position I. Okay, somehow I want to know if that rectangle there is the same as other dot rectangles at position I. But now how do I compare them, right? That's the issue. Oh, maybe, sorry. Better? Okay. So now how do I compare them? So now I got two rectangles. This dot rectangles at position I, and also other dot rectangles at position I. How do I compare them? Apparently, it would be wrong. It would be wrong if I simply say equals equals, right? If I simply say equals equals, I'm comparing the addresses, which means the areas do not matter. Okay. So what I should do, so that's why I deliberately chose rectangle 2 over here, because now I can simply just say dot equals here. Okay, but now I need to see why it will not compile. So let's see this. Okay, can we just say this initially just false? Oh, sorry, no. Initially it should be true. Yeah, you're right. Yes. Okay, here. Okay, so again, because you can see the rectangle type is actually rectangle 2, this is the class where the equals method has been redefined. Okay, so now that is why when I say this dot rectangles I, that is going to be of type rectangle 2, which has the equals method redefined. So later I'm going to show you in a moment that equals method here is going to be the redefined version that is going to compare areas. Okay, and we're done. So this is a version without any early exit. So maybe for the purpose of your midterm, I can show you also the version with early exit. Okay. I'll show you that version as well. So let's call this version 1 without early exit. Version 1 without early exit. Okay, let me comment that out. Okay, this one will work. So now version 2 with early exit. The version is going to be very similar. So we're going to say integer I equals 0. So now we're going to add one more condition to the exit condition. Let me just also define a Boolean. Oh, actually here. We're going to say result and also I less than the number of rectangles, I plus plus. You can see the only change is I also add the result into the exit condition. That's what we learned from the loop lecture. So now I'm going to say result is simply assigned. We don't need conjunction anymore, because as soon as the result becomes false, it's going to force the for loop to exit. Okay, we can copy exactly this line here. That's version 2. Yeah, you should really understand both versions, right? Both. Okay, let's now go back to the tester, and then let's try to do some tester code, and then make sure. Now, when we run the equals method, it's going to return true. Let's now go back to tester here. So now, we're going to do something similar. So now rectangle collector 2, RC3, new rectangle collector 2. Okay, also rectangle collector 2, RC4, new collector 2. Okay, so now let's say for RC3, we're going to add rectangle R3. And remember R3 and R4, they are rectangle 2. Okay, remember that. Okay, and then we're going to say RC4 dot add rectangle R4. So now we're going to do almost the same print statements to make sure equals still returns false, but dot equals is going to return true. And then I'm going to show you in the debugger how it actually happened. So now let's do the following. If we do this, system out dot println. So RC3 equals RC4. RC3 equals RC4. Okay, that one, and also system out dot 3 dot equals RC4. RC3 dot equals RC4. Okay, so now you can see RC3 and RC4, they are now of type rectangle collector 2, which does have their equals method redefined. So now we should expect to see false and true. And then I will see the debugger. Yep, false and true. And now let's run the debugger to see how it actually happened. Okay, if you put a breakpoint here, yeah, so we are okay. Put a breakpoint here, so we'll stop here and see which version of the equals method is going to call. Okay, so now if I say run debug as Java application. Okay, so now you can see we are here right before we say RC3 dot equals RC4. Let's say step into, just a string, so we can step over, that's fine. And step into again. So now you can see that we are now in the equals method of the rectangle collector 2. Okay, you can see rectangle collector 2 here, and which is going to run the loop. And now you can see, remember, the number of rectangles for each one of them is just 1, right? One has one has R3, the other one has R4. So now be careful here. So now you can see when we run the loop, we're going to say this dot rectangles I, this dot rectangles I dot equals other dot rectangles I. Question for you: if now I say step into, which version am I going to see for the equals method? Rectangle 2, right? Because we did redefine that in the rectangle 2 class. Okay. Very good. Okay. If we do that, you can see now we're in the equals method in rectangle 2. And that one is really going to compare the area for individual rectangles. Okay, that's why one is 3, 4, the other one is 2, 6. They will be considered as equal. Okay, so that's why you will simply see result has been assigned to true. Okay, it remains true. Okay, so now result is going to be true when you return. Okay, any questions about this? Okay, so now I have another about 10 minutes, and I'm going to blow your mind by introducing a third version. Yeah, you no, sorry, I'm going to do that. The bright side is it's not on the midterm, but the downside is on the final. But you still have lots of time. Okay, let's see. I'm going to introduce another version to you. But hopefully this one can clarify some things rather than confusing you, I hope. Can we now create another version of the rectangle collector. Okay. Don't worry. Eventually, I'm going to draw some diagram to show you. Okay. So now, just let me remind you about the decision I made. Remember, in the rectangle collector class, rectangle collector 2. Let me just show you here. In rectangle collector 2, I chose the type to be rectangle 2 explicitly. Okay? My question would be, what if now I create another version here, I would change this to be rectangle, but I still redefine the equals method. What's going to happen, right? And I'm just trying different combinations here, right? Okay. Let me put on the board. So before I do that, I better tell you what exactly I'm trying to do. Okay, so now let's see this. So here we got rectangle. Actually, this might be the best way to illustrate. Rectangle collector. And also we have rectangle collector 2. Okay? And also the one I'm going to create is called rectangle collector 3. Collector 3. Okay? So now let's make a table to make things very clear. The things we care about is as follows. First of all, what's the type of rectangles that they're trying to use? Okay, for rectangle collector, you simply use rectangle. Okay, for this one here, we use rectangle 2. For this one here, I'm going to do a contrast with this one here. So it is going to also use rectangle. Okay, and to remind you about it, in the case of rectangle, the equals method was not redefined. And in rectangle 2, the equals method was redefined. And similarly here, so let me just look at another better marking here. No, I don't. Anyway, do I have any? Okay, good. So now this case here, equals method not redefined. Not redefined. Okay, another thing I care about is whether itself has the equals method redefined, right? Because rectangle collector is a subclass of objects. Rectangle is also a subclass of objects, so we've got different equals method here. Okay? So now here is another thing I care about. So equals method, okay, for comparing the collection of rectangles redefined. Is it okay? So this one, no. This one, yes. And this one, no. Okay, so now, let's see this. When I compare these two over here, when I compare these two here, I'm really comparing to see, when I use rectangle, I use rectangle 2, and also to see if the equals method is redefined or not. Okay? The new version I'm trying to create over here, I'm trying to do another comparison. So for this one here, I'm really trying to see, if I try to use the rectangle class, okay, actually no, sorry, I forgot. This should be yes. Okay. So the only difference is, so in this comparison here, so both of them have the equals method redefined. However, they're using different types of rectangle. What's going to happen? So that's the comparison we're trying to make. Okay. So please, just try to just kind of study this table here, so that kind of give you a roadmap. Now I'm going to do that. Okay, let's now create the new version. Okay. Yep. So now let me go back to Package Explorer. So can we just create a new class there? New class rectangle collector 3. Okay. So now let's try to do that. Rectangle, right in the rectangle 2. Rectangle here, rectangles. And also integer the number of rectangles. Rectangle collector 3, that's a constructor here. So now we'd say rectangle equals new rectangle, let's say 10 as before, nothing special here. And then the number of rectangles is assigned to 0. And now let's have also the mutated method, void add rectangle, so it's going to be rectangle R. Okay, for rectangle here, we're going to say rectangles at number of rectangles assigned to R, and number of rectangles plus plus. Okay, so now here comes the difference. So the only difference from rectangle collector 2 is the type of rectangle is different. But we're also going to apply the same redefinition for the equals method. Let me do that here. Let's do that quickly. So Boolean, and then we say equals rectangle collector 3. Okay, other. First of all, we can compare the size of the two. If let's say here Boolean result initially just true, and then eventually we're going to return the result. So now we'd say if this dot number of rectangles is equal to other dot the number of rectangles, then we have the potential for them to be equal. Otherwise, of course, they are different since they don't have the same number of rectangles. Result is assigned to false. The same as before. So let me just do the version without any early exit, just to make it easy. Okay, so now we're going to say for integer I, 0 I less than the number of rectangles I plus plus. And then I'm going to say result equals result conjoined with this dot rectangles at position I. And then now I say dot equals. So we'll see in a moment, okay? And other dot rectangles I. Okay, I'll let you finish typing first before I go on. Yeah, sorry, it's a bit. Okay, like that. Okay, so now let's go back to the tester. Okay, so let's now do rectangle collector 3. Okay, make sure you can see that. So now let's RC5 new rectangle collector 3. Okay, and rectangle collector 3 RC6 new rectangle collector 3. Okay, RC5 and RC6. And we're also going to add RC3. So now we're going to add 2 rectangles into it. So RC5 5.add rectangle R1 because they take rectangle rather than rectangle 2. Okay, RC6.add rectangle R2. Okay, now we're going to ask the same two questions. Okay, system.out.println. First of all, RC5 equals RC6. This one, there should be no question about it. That would just be false. But now here comes the critical part, the tricky part. Okay, so let's say system.out.println. RC5 dot equals RC6. One thing to remember, RC5 and RC6, they are of type rectangle collector 3, and we did redefine the equals method in that class. Okay, so we would expect this to be true, right? Somehow, we would. Let's see if that's the case. You might think it is the case.
Doesn't it have to be false?
Oh, we'll see. Yeah. Yeah, it was false. Okay, if that's true, then there's no point of illustrating this, right? Yeah, it's false. Okay, so I would like you to maybe you know the reason already. So maybe just please keep silent for a moment. That's good. That's good for you. Okay, so now let me just. Okay, apparently you can see it used to be true, but it's now false again. We have to understand exactly why. So now if you go back to rectangle collector 3, okay, so now you can see that we did redefine the equals method for rectangle collector 3. We did do that, but somehow when we compare the two rectangle collector class, collector objects, they are not equal. What's wrong here? Okay, take a guess. I tell you what, line number 3 is the key. So now if you compare these two classes, rectangle collector 2 and rectangle collector 3, the only difference is the array type. In one case is rectangle 2. The other case is rectangle. Right? In the rectangle class, we did not redefine the equals method. But in the rectangle 2, we did redefine the equals method. So the problem is, although at the rectangle collector level, you try to execute this version of the equals method, but when you try to execute this line over here, when you say this rectangle's I, which is a rectangle, and if you say dot equals, it is not going to call the right version. It's going to call the inherited version from the object class, right? Because that class did not redefine the equals method. Let's verify this, and then we're done. And we'll do the toString method after midterm. Okay. Okay, I would like to go back to the tester here. Can we just put a, let's remove the previous breakpoint here. Okay, remove it. Can we just put a breakpoint here, right before we do RC5 dot equals RC6. So now run debug as Java application. Okay, so now, first of all, question. If I say step into, not yet. So let me say, if I say step into here, it will just be a string. Okay, now, if I say step into, which version of the equals method am I going to step into? Any idea? What's the type of RC5? It's rectangle collector 3, right? So now, in rectangles collector 3, we did redefine the equals method. So it is going to call that version for sure. Okay, that's how you judge. Okay, if you step into it, yeah. So now we are here in rectangle collector 3 over there, and now that's the equals method. Okay, that's fine. So now we are now trying to see if this dot rectangle 0 dot equals other dot rectangles 0. So now critical points. If I step into it, which version of the equals method am I going to see? Object. Because if you look at the type of the rectangles over here, it's just rectangle. Remember, in the rectangle class, we did not redefine the equals method. So it's going to use the version from object class, right? Okay, if you step into it, so now indeed, we're now in the equals method in the object class, not in the rectangle 2 class, right? Okay, so that means, although at top level we're trying to compare the length and how many rectangles we have in the rectangle collector, but when we get to individual rectangles, we're only comparing the addresses rather than contents. That's the problem. So my point is, choosing the right type for the rectangle is also very important. Okay, so my suggestion would be, maybe you will be worried about the midterm before Friday. Maybe after the midterm, yeah, try to study this example carefully. Okay, very important. Especially why we actually created the 3 versions to contrast. Very important. Okay. Okay, if you have no further questions, we're done for today.